Hi, I'm Tim. Feels warm in here. Try to keep this exciting. This is the PHP Daemons and long-running processes. I'm assuming this is all the one that you wanted to be at. What I'm going to do is go over a little bit of background on what this all is and how you would put it together. Then we'll take a break, since this is a workshop, and come back and do some code exercises to go through and see some different long-running processes, consider some different things you'd have to do with them. Let's see here, what do we got here? If you have any questions, feel free to interrupt me at any time. It's much better for me to, help you understand whatever it is that you're trying to understand than what I think is, interesting about this stuff. So feel free to interrupt me. That's the only other thing. Well, you know what? Let's start it this way. The question, like I said, the obligatory. This is me. I'm Tim. You can find me on Twitter at TJLytle. Feel free to ping me with any questions afterwards if you have them. I work at PhoneBurner now, building some interesting telco stuff. I've been building things like this for years, using daemons and long-running processes to do things offline with PHP. Was in the past a developer evangelist at a telco API, Nexmo, their sponsor here. So we'll be using some of their service as examples today, just to kind of make things interesting. So I'll ask this question. You're all here in the long-running processes talk. Why do you want to either run a PHP daemon or a long-running process? Not all of you, but just some of you. Yes. Okay. So you need to process stuff offline. You can't do it in a request. Yes, you had your hand up? Okay, so some aggregation that just takes a long time. Yeah.
We have a lot of background cast reports is one example.
Yeah.
And like sending text messages, things like that we don't want to do synchronously. I mean, reports we kind of can't do synchronously because some of them take a few minutes.
Forever, yeah.
And currently we have them on a scheduled basis, but it would be great if it could be on demand and quick.
Right. Anyone else? Yeah. Okay, you just don't want to do something in the request process for some reason.
Sure. I mean, really, it's not needed right this second, but it takes more than a few seconds to do it.
Right. So you're trying to do some optimization, make sure your pages respond quickly. Yeah, I think it boils down to all that stuff is right here. Either you've got something that takes a lot of time to do, like some reports that take forever, video processing, something like that, and you need to do it outside of a web request because you don't want the user to hit generate report and be like, wow, that's kind of slow. You want to hit generate report and then tell them, we'll email you it when it's ready, or this page will refresh automatically. It's something a lot better UI, so they can see something that's like, oh, the report is slowly being generated, and if they hit refresh, it doesn't try to do the whole thing over again, right? Because with PHP is very tied, generally speaking, to the request response model. You make a request, it spits it back, and then everything's gone. Even the keynoter was just talking about how at Slack, there's a lot of benefits to that because she can go and use global variables to do some internal caching. She doesn't have to worry about that somehow being around the second request because it's gone. It's not like if we have something like a node process that sticks around and handles an inbound request, that data stays there. So there's a lot of benefits to that, but it's very much something that's a pattern for the web, not necessarily the command line and being a long-running process. So we have things that take time like that, and you mentioned stuff like sending SMS. Or any type of outbound communication. There's two sides to that too, right? It's things that may take time to do that, but generally speaking, SMS API will get back to you pretty quick. There's a lot of things though that you want to make sure it gets done, because if it fails, if for some reason the render fails in the user's browser, you still want it to happen. You don't want them to go, oh, whatever, I'm going to close this and navigate away, or hit refresh and it happens twice now. So you want to make sure that things either happen, must be successful, you know whether or not they're successful. And there's also these things that happen over time, right? Not everything can be reduced to an inbound web request. There's some things like, well, an external system changed, and I have no way of knowing that. I actually have to ask it that, or I have to somehow wait for a video that's to be processed to end up in a queue or something, and I don't want to pull that every once in a while. I want to I want to be able to get it on demand but efficiently. So I guess here's a good question for this group, for this talk. How many of you have had a cron job that's just all asterisks? All right, yeah. That you just run it every second because there's something that you want to do every second, and it's usually something like go check the database to see if there's a new row that doesn't say finished, right? I inherited a project like that years ago, and it was supposed to be a web crawler, and it was just dying because that's what they were doing, but the problem is because the cron jobs were running every second, they were stepping on each other. They were pulling they were pulling the same rows out, updating the same rows, and they found as soon as they tried to crawl any site of size, it stopped. So on that, how many of you have had or have now like a MySQL table, or I'm sorry, a MySQL table that has a field that's like checked out, or some type of indicator that says don't touch this, the job's touching this, and then the painful logic required to know when the job fails. How do you know it failed? Because it didn't update the row. And then it's just sitting there. And then you got like this other query that's like, well, if it's checked out, but the checkout time was 20 hours ago, then it's probably failed, so I should uncheck it out, right? And how many of you had to log into some server like in the middle of the night because the report job stopped and you needed to restart it because it just didn't restart automatically? Anybody have to do that? Okay, all right. So those are all things that long-running processes can solve, or all things that PHP daemons can solve. Oh, that's another interesting question. How many of you say daemon, and how many of you say daemon? Daemon? Okay, and how many says daemon? All right, well, it's a good mix. It's a good mix. I asked that, I think the first time I did this talk, and most of the room was like, it's definitely daemon. Well, I agree. I agree. So I asked that, and I thought, well, since everybody's familiar with that, I don't want to make everybody kind of go, that's weird, that's weird. So I'll start saying daemon, and I forced myself to say that. At the end of the talk, someone dinged me a star and joined in. They're like, it's demon, and I was annoyed every time he said it. I was like, I agree with you, man, but come on. So we're going to talk about how to do these things that we try to do, and we have all these kind of kludgy ways to do them the right way, with the understanding that in PHP there's probably about 15 ways to do something. 7 of them are arguably right. 7 of them are what we'll try to do, and we'll argue about whether they're right. So this isn't the only way to do this stuff, but hopefully, it'll put you in the right direction about what you can do. So let's see here. Oh, and also, when we get to the workshop part of it, have in your mind whether or not you're going to want to follow along on your machine or not, or whether you just want to kind of watch me walk through it too. I will not make you suffer through watching me type code at a not standing desk. I'll just check out things and kind of step through it. But you can do that too. If you're going to do that, keep in mind for your development environment, basically you just need, you'll need, for one thing, you'll need some Twitter credentials, and any PHP development environment. For the other stuff, you'll need Beanstalk and MySQL. So there is in the, did any of you see the GitHub repo? That was, okay, so there's a GitHub repo attached to this. There's a couple Docker files in there that'll run. There's also an old Vagrant file that I don't know if it'll work anymore. I haven't used that for a while. But when we come back after the break, I'll kind of walk through that stuff. But have an idea whether or not you want to do it, and maybe when we come back to the break, shuffle so if it's everybody that wants to walk through is in the back, you're actually in the front. So it just makes it easier for me to help. All right. So how do we do this? How do we create a long-running process? Well, first thing is you just don't exit. That's pretty easy, right? Because the natural progression of a PHP script is to run to the end and then exit, right? So we got to find a way to not exit. And then we have to, if we exit, if something happens and we have to stop, we want to stop responsibly. We don't just want to stop in the middle of a job. We want to make sure if we stop, we know what work's been done, we know what work needs to be done, and we can, either we can resume or we can recover. We want to make sure that we stop responsibly when we need to stop. And then finally, if we need to, if we're a job that's supposed to continue to go, and we're not just like a report generation that may run and then be done, but we're something that just needs to sit there all the time doing something, then restart. If you stop, you want to stop responsibly, and then restart it. So, how do we do that? Well, it's pretty easy. I think we all know how to do that. Just go while true, right? Chris Tankersley is like, I don't even know why you give this talk. It's all true. How in the world, what else is there to say? That's really what it is, right? First thing we do is this is basically a PHP daemon in a nutshell. You're gonna set up some things. It's just gonna be like like the bootstrap that you have for any other application. This is where you're gonna do stuff like connect to your database, maybe set up some dependencies, make sure your auto-loading is in place, whatever bootstrap script you have for the rest of your site. Oh, and I should mention that too. PHP is not a language that is designed necessarily for this. It's designed for web requests. So why would we want to do this stuff in PHP and not like every PHP? How many of you, I'm like every PHP developer, I think, I aspire to learn Go. Anyone else? No? Okay, I'm the only one, because I see all these talks about Go for PHP developers, and I too would like to learn Go. I haven't, but I aspire to learn a language like that and play with Go. I play with it a little bit. But so why don't we just switch and use a different language? It's late in the day, so this is going to be an interactive. I'm going to make you answer questions so you don't fall asleep. Yeah. We already have a bunch of code that we're using. We have whatever our domain model is and whatever our data mapper is. It's already written in PHP. If we're going to interact with all that stuff, why not use the same language? So yeah, that's one reason. Any other reasons? Yeah. Yeah, lots of, PHP is a language that has a lot of libraries. So if you're looking for something that you're like, oh, I wish somebody else had already solved this problem, they probably have. Any other thoughts? Yeah. Right. You don't have to, it's something that you can actually be familiar with and you can work efficiently in. There may be, like you see Slack transition to Hack, which I know is basically PHP adjacent, but your team may slowly move to a platform that may be better at whatever your problem, your use case, your problem domain is. But that's going to be a slow thing. You're not just going to pick up the best. I saw a tweet the other day. The idea that when we say, oh, you just use the best tool for the job. Well, in the case of programming, there's a lot of what am I familiar with to begin with. It may be a better tool, but if I don't know how to use it, there's no point in me switching to that. So yeah, there's a lot of reasons why we would do this stuff that PHP may not be naturally good at if in PHP. So your bootstrap, that's where we set up everything. It looks similar to whatever your application probably already does. And then we have this conditional, this while loop, that's just going to keep running. But we don't really do while true because that would never exit, right? So while, and then we have some variable there. So this is what's going to determine, that run is going to be what determines do we continue to run. I have a note there, and I'm trying to remember because I've done this presentation before. Use next instead of a for each loop. Oh yeah, that's right. If you're iterating through an array, then you can instead of using a for each, which is, that's natural as a PHP developer. You want to go through all the elements in an array. You use for each. Is to use next to pull something off of the array. The reason why you would want to do that is so you can still control your loop. You may have a really big array of stuff, some big bunch of jobs you're supposed to do. Instead of going over that in a for each that you can't exit out of gracefully, just grab the next one off the array or do an array pop or something like that to grab that element off so you still have this idea that you can exit. You can exit if you need to. So that kind of run condition, that flag is kind of important. You're going to do some really important things, right? You're going to send that SMS. You're going to build a report. You're going to pull in a gazillion records. Oh, you're going to archive. You're going to archive 17,000 members from a Slack channel. You're going to do something like that right there. And then maybe you're going to sleep. Now, why would you sleep? Right, because there may be some condition, depending, you may not need that. Depending on what your job is. If your job is just pulling some records from a database and processing them and then you're done, you may not need that. But if what you're doing is maybe pinging an external service saying, do I have new work? And you don't have something in there that gives it a break, you may end up either, consuming a lot of resources on your machine, consuming a lot of networking resources, just basically annoying people that are involved with this process, right? Or, if we'll talk about queues in a bit, but if you have a good queue system, maybe you just do a blocking wait, which means I'm going to sit here and wait for the queue to give me a job, something like that. And then we do it again, right? And then something somewhere in there changes that run flag, and then you exit, right? But you don't just exit because you have some shutdowning things This is where you can tell the user, hey, we completed successfully. Or this may be where they tell the user the process stopped for some reason, and I need to report why it stopped and how you can resume and log some things because you know the work's not done, but I need to tell you about that. If it's a daemon, and this is the place where you would want to restart it, right? So we have all that. It's pretty simplistic. That's the talk, right? So thank you. No. It's a little bit more we can explore that because this isn't something we normally do. So the setup things is pretty easy, but how do you control this process? Because once you send a PHP script off into the world to do its thing, how do you influence what it does? How do you? Like if you're running a command line script and you do PHP something, you're like, oh no, that was on the production database. What do you do? Yeah, you hit Control C, right? You're like, I need to stop this thing right now, right? That is how we interact with it. Unplug the computer. He takes it a step further. Then he realized he was just SSH'd in and that did nothing. So we hit Control C. That's how we stop a process that we're running. What is Control C? Signal. It's process signal, right? So this is not, I'm going to say this is not going to work for all of you that are running PHP in a Windows environment. And I'm sure, how many of you are running PHP in a Windows environment in production? You are? You're interesting. I want to talk to you about that later. No, but that's fascinating because you don't have this extension, and he's not here. It doesn't usually come to World. He used to come to Tech all the time. There was a guy who gave a talk on how he basically hacked this into Windows. I forget what he did. It was almost like detached from the process, and there were some crazy things he was doing because you don't have these control functions on Windows. But the process control signals, and there's the PCNTL extension that you'd have to have installed to make all this fun stuff work, which I think, now come to think about it, because the past couple of days and last night, I took my examples and made them work with a Docker image for PHP 7. So I think in PHP 7 and maybe any modern version of PHP, they may be included by default because it just worked. Is 7.1 they're included by default? Okay, so that's why I'm like, everything I ran worked. I didn't install these though, so that kind of concerned me there for a second. So PCT, I'm just going to call it process control underscore signal. That is a method that will let you respond to signals. So in that, you can give it a callback and a signal that you want to listen for. And now your script will interrupt that signal and execute some type of callback when you get that signal. But you don't want to declare that, or you don't want to define that unless you use one of these two. Because that'll interrupt the signal, but these are the things that tell PHP how often you want the signals delivered to your process. So if you define that without defining these, PHP will tell the operating system, I'm going to listen to the signals, you don't worry about them, but then it'll never deliver them to your code. So what these two things do is this function right here, process control signal dispatch, says, I want you to take all the queued up signals that you have, I want you to deliver them now. So if you're working on some code and you're like, well, this is exactly where we would want to respond to signals from the operating system, you might run that. Declare can be used for two things. One thing is to declare stuff, right? The other thing is if you declare ticks equals something, you're telling it every so often, I want to check for new process and control signals. The ticks are, you might be able to think of it as kind of like an expression in PHP. The only problem is it's not an expression in PHP. It's an evaluation in the underlying C code. So it's not quite a one-to-one relationship to say a line of code or a call or an expression in your line of code that every time one of those is evaluated, it'll get called. It's more or less what the instructions are happening on the C side of things. But you can think of it as you set a process or a PCNTL you declare ticks equals 1, then you're going to be checking very, very often. If you declare ticks equals 10, you'll be checking less often. If you declare ticks equals 100, even less often. You might need to play with that depending on how much you want your process to, how responsive you want it to be, or how soon you want it to exit when you give it a signal. Any questions about all this fun stuff? Pretty straightforward. So with this, now we can interrupt any signal, not just Control C, which is SIGINT, but we can intercept any signal and run code with it. I say any signal. There's one signal you cannot register. Any idea what that signal is?
Whatever the kill-9 signal says.
Yeah, sig kill. The thing that says, like, really, really kill this. Because if we somehow screwed something up and we didn't handle it correctly, you could have a process that then would be unstoppable. So, which, although that may sound interesting, I have an unstoppable process. My PHP, you can't even stop. Probably don't want to do that. So, let's see if I'm missing anything here from my notes. Doesn't look like it. Next thing we have, so that's how we'll set that run flag, right? So the idea would be, here with the process and control, the simplest thing would be to say, if I get a signal, Control C, so I'm going to register for a SIGINT, and if I get that signal, my callback will say, set this run flag to false. And what that gives us right now is now, even if I hit Control C, at least this loop will continue. So when you accidentally run that command on production, you hit Control C and you have no idea, like, how much did it do? Did it do a whole thing? Did it do half a thing? How do I know how many records it actually updated? You'll know that at least it did a whole thing. Wherever it stopped, it did the entire job before it stopped, before going to the next job. Because it doesn't matter where the signal's intercepted, right? If all it is doing is changing the value of run, then you'll still be able to run through that loop and then exit gracefully. So we can use process control to signal things into the PHP process. And that's not just Control C from the actual process. That's really anything that's on that same box can send a signal in there to control it. And you can do other things. I mean, you don't even have to. You're not limited to just signaling, hey, I want you to stop running. You can give it other signals to change its behavior on the fly without restarting it. I should mention Cal Evans has a good book on signaling PHP. It's a real simple read. It's like, I don't know, it's not too thick. I say thick. I bought the ebook, so I really don't know how thick it is. It's not too, I don't know. Its file size isn't too large. But no, it's a real simple read, and it just goes over everything you need to know about how to capture those signals and what they're all about. So if this is something you're going to do, it's a worthwhile buy. I should say that because I haven't written a book, but once I do, I'll definitely not be pushing his. Though it is a good book. All right, what else do we have here? So we got queues and things like them, right? So where do you get these jobs from? Or where do you get the stuff that you're going to work on? If it's a report and you're just slurping in a bunch of database records and building a report, that's one thing. But what if it's a bunch of things you have to do, like you're going to be processing videos, right? Or a bunch of thumbnails that need to be processed. How do you know? How do you get them? Do you do a call, like select? First of all, you'll never do select star, right? But we will. Select star from images where thumbnail is null, and then just pull them all back in. You can do that. There are better ways, though, right? So there's queues and things like them. PHP has a lot of queues available to it. There are, let's see, Gearman is one. Has anybody played with a queue before or worked with queues? I feel like some of you, yeah, okay. So how many of you use Gearman? Okay, Gearman's interesting because it has native bindings. There's an extension that you can use with PHP. Gearman, though, I've always found to be a little weird. Maybe you guys have had success with it. I've just found it a little odd at times. But there's Gearman, which is kind of not built in, but can tie very closely to PHP. Beanstalk D is a good queue. It's ridiculously simple. I don't believe it distributes, but it's pretty simple. RabbitMQ is popular, and there's a lot of interesting things you can do with it. You can do more than just simple job queues. Redis can also be used as a queue as well as a cache. In fact, you can use other things as queues too. You can kind of tweak how you use them to turn them into queues. The important thing, though, with the queue, well, we'll get to that in a second. Then SQS and SNS. Anybody use those? Those are AWS's services. Okay, a couple, yeah. So SQS and SNS tie together really nicely. SQS is our queuing service where you go out and ask for a job and it'll give you the next available job. SNS is where you push you publish an event to SNS and it'll push it to a bunch of endpoints. What's interesting is some of which can be queues. So if you wanted to process, say, a video or an image or something like that, you could push like this file up to a SNS endpoint, and then that could make a bunch of queue jobs because maybe you need to do a bunch of things to it. You need a couple different, well, if it's a video, maybe you need to transcode it. You need to pull out a thumbnail image. You need to do, I don't know, image recognition on the whole thing so you can find things because you're a search provider as well. So you can tie those two aspects together of that like kind of distributed job, on demand, or not on demand, more like a push service with the queue service to just set up all your jobs automatically. But the important thing about queues, the thing that makes them very useful, is this idea of blocking. So this idea that you can just go out and say, hey, give me the next job. Even if there's not a job, I'm cool with waiting, and I'll wait for you to get back to me. So most of these queues have the notion of blocking. Some of them have a timeout, like SQS. I think will block for, I want to say 30 seconds before it'll just fail. Not fail, but just say, hey, we don't have a job, sorry. So notion of blocking lets you just sit there and wait. So you can have a PHP process just sits there, does nothing until another job becomes available. Important thing, anything that might be important there in terms of controlling your job, though? Yeah, exactly. Run into that, when you're playing with queues, you'll run into that frequently if you're blocking and then there's no jobs because you're in development and you're not pushing any jobs toward it, and then you're like, oh, I want to exit it, and it won't exit gracefully because it's not executing any code, it's blocking it. So when it listens for the signals, it's a byproduct of the way PHP passes the signals to the process. It has to be doing something to get the signals inbound. So you'll generally not want to block forever. You'll want to block for a reasonable amount of time, and that gives the process time to answer any signals, shut down if it should, and then go at it again. The idea of reservations are important for queues. That means if I have a bunch of, and we're not going to talk about how a queue is built, right? We're going to assume that they exist and they work and they're a great tool that we can use. Reservations is important because that's this notion of if I stick a bunch of jobs in a queue, and then one of my process comes out and says, give me the next job, the queue passes and says, here, you got job number 5. And the queue's not going to pass that out to anybody else. So we solve some of those weird database record locking things where you're like, oh, I don't know if another process is actually processing this row now. Should I also process it? The queue manages all that. It passes it to the job. And usually queues have have something that you can define called a timeout, or how long the job can go before it says, I bet that process failed. I'm going to stick it back in the queue so another process can pull it out. Usually queues that have that notion of reservations also have this ability for your process to say, hey, I'm still working on it, to kind of touch the job and say, don't time it out, I'm still operating on it. I know it took a long time, but I'm still here. And that's important because you don't want to be like, well, you know what? Transcoding a video could take 15 minutes. So now my queue time to live for a job is 15 minutes. So if it fails at 1 minute in, I have to wait 14 minutes before the queue puts it back in. That's not helpful. So a job time to live of maybe 30 seconds, and I make sure my process is at a regular interval touching it and saying, I'm still working on it, I'm still working on it. Make sure that when it fails, it gets put back in the queue right away. Along with that notion of reservations, a lot of these queues have this idea of, I think it's both Rabbit and SQS called things like a dead letter queue, and that's where if this thing comes back 4 or 5 times, we're going to stick it in a different queue that no one's listening to that you can go and inspect and be like, why does this job continue to fail? Other queues like Beanstalk give you the ability to do that, where you can say, I want to bury this job. I don't want to release this job. I don't want to delete this job. Delete means it's done. Release means I couldn't fix it. I couldn't handle it. I want you to put it back in the queue so you can give it off to another process. But you can also bury it, which means keep it in the queue. I want to know it's there, but I don't want anybody to see it. And in fact, the way different queues operate, you may be able to look at that buried queue and then shift jobs right back into the normal queue. Once maybe you realize, oh, we had a service that was down, that's why all these failed. Now shift them back in and we can retry them again. And there's streaming, which is kind of like a queue, but without the notion of jobs. So how many of you ever played with Twitter's streaming API? Okay, so Twitter's streaming API is a live feed of tweets in real time. Yeah, DynamoDB has a similar notion, and the idea there is they just push the stuff down. I think Twitter separates it by two-line feeds or something like that, and says, you know, we're going to send out a tweet, and every once in a while we'll send down a new line just to keep the connection active if there's not that many tweets flowing, or you know, and with Twitter, you know, you or I can't get what they call the fire hose, which is the whole thing. They make sure there's some filters on it that you have to define some query parameters, so you're only getting a portion of it. And there's a lot of data coming down there, and it's like a queue without the idea of reservations, because it's not on demand where your process goes and says, hey, do you have another job for me? I'm ready now. It's just like, hey, here's all the data, pushing it down to you. You better be able to take it. And in fact, like when you work with Twitter or a stream like that, practically a lot of the step that you do is I'm going to consume this stream, which is an always open HTTP connection with data being pushed down. And every time I get a block of data, I'm not going to do anything with it because I have to be very efficient. I have to be ready for the next block of data. I can't just not, you know, I can't just not accept the stream. Twitter even, I think, they may have changed this. Twitter should show you in their dev tools like how backed up you are. Like, this is all the data we wanted to send you. You know, the buffer we allow you to have, this is how filled it's getting because you're not dealing with it fast enough, right? So you, in situations like that, you want to deal with the stream. You want to get these jobs out as soon as possible. You want to be able to get the next line, which is new data. So the pattern that you see a lot is you consume one thing from the stream, and then you stick it into your own queue. Because that's a really fast operation. Just throw it in a queue, and then let your workers that are going to parse it and stick it in a database and do all that kind of fun stuff actually do their work. So you can see the streaming and the queue work together. Yeah?
How does Celery fit in with this sort of?
I'm going to need to know what Celery is.
Okay, that was my question. It's just like, what is Celery? But I know that Celery is like on top of Beanstalk or on top of RabbitMQ.
Oh, okay. I don't know. Do you know what it's supposed to do? Because now it's sounding more familiar than I know that
I couldn't understand the difference between like what is Celery's value add on top of Beanstalk or RabbitMQ.
I'm going to hesitate, you know, just moving and Googling it live because that could be dangerous. But yeah, I'll take a look and we'll see. Maybe it's it could slurp stuff in and then just throw it in the queue. And then finally, there's Daemons, which are pronounced demons and not Daemon, right? Yeah. All right. Yeah. So how do we get our PHP process to not shut down, or if it shuts down, to restart automatically? How do you do it on Windows?
On Windows, I created a Windows service that does check.
So you have a separate service that says, is my PHP process running? And then if that's a no, it just is like spin off the PHP process. Right, so that's the same basic way that you do it in a Unix environment too, or a Linux environment, or you know, a FreeBSD environment that's also known as Mac. The same process is you have another thing that watches it to make sure it stays up. The way things that naturally run as daemons do that is what's called forking. We know how to fork a process in PHP? Has anybody forked a process in PHP? Yeah? Yeah, all right, yeah. Fun stuff.
We have code that does it. I never did that.
Yeah. You probably shouldn't do that, right? It says so right in the slide. So I saw it in the conference on a slide. It must be true. You probably shouldn't fork PHP. It's weird, you know, because you know, what do you do after you fork it? You know, what does the code do after it forks it?
I don't know.
Okay, so hopefully it works, right? So the standard process is once you run a PHP process, it forks, and that creates a copy of itself, and then it looks at its PID, its process ID, and then says, am I the process that started this whole thing? If so, die. So the parent process dies, leaving the child to just be running there on its own, not connected to your terminal, not able to be interacted with through those mechanisms, not tied to your shell, So when you close your shell, that process isn't attached to it. It can run on and do whatever it wants to do. And I don't know. It's all a bunch of fun Unixy stuff that you probably shouldn't do with PHP, because then you also need another PHP process to look at the process, to refork it if it dies, and all that kind of fun stuff. And there's tools that make it really easy to do that without you having to do complex and crazy things in PHP, though you can. I've seen it done. It's kind of weird, fun to play with, but you probably shouldn't do that. How many of you use Supervisor D? Anyone? Okay, a couple, right? Supervisor D is a Python application library, utility, whatever you want to call it, that you give it a configuration file, says I want this script to run. In fact, I want this script, 5 of them to run. And you tell it to start that, and it'll spin up 5 copies of that script, and it will keep an eye on them. And it'll make sure, if for some reason now there's only 4 copies, it'll spin up a 5th copy. And it'll make sure that if any of those processes die, it restarts them automatically. So Supervisor D is used a lot in this context. In fact, just started a new company 2 weeks ago, and they do some jobs, and that's what they're using, Supervisor D. I used to recommend Upstart or Systemd. Upstart's no longer supported on Ubuntu. They dropped it in favor of Systemd, as did Debian and a bunch of other distributions. Have any of you played with those two? Okay, Brian, yeah. Yeah, so they're really easy. Like init scripts, I find, I don't know, maybe I'm not normal, and init scripts are really easy for everybody to understand, but I find init scripts a little hard to understand and write and figure out what's going on. Upstart and Systemd kind of wrap all that to say, give me the process. Now, you can tell it that your process is going to fork itself, is going to demonize itself, or you can tell it, nope, it's just a simple process. Please keep this thing running for me. And what they'll do is you can define like unrun levels, whatever, 0 through 5 or 6 or how many run levels there are. I want this process to be up. So then Upstart or Systemd, which are system level process management concepts, utilities, something like that. For some reason, the correct terminology escapes my mind. But they'll keep an eye on the process, and they'll restart it if it fails. And that's also the same way you'd interact with it. So just like you do like you start Apache or Nginx with a service, Apache 2 start, something like that. You can use that same command style with these, because behind the scenes, that's what they're using. Now, you may still use like the set file, like set init.d, Apache start or something like that. Well, on most of these systems, Debian, Ubuntu, you can also use Upstart or Systemd, and they just kind of wrap that, and they're one way, and things are migrating that direction to be using these service commands to stop and start services. I forget what Systemd is. I think it's system control. Does anybody know? Yeah, systemctl. And then you'd be like systemctl, your process name, like my fancy daemon start, or status, and it'll even tell you the status. So if you've played with Systemd then?
Yes.
Okay. Remind me, Upstart is really weird to start up multiple copies of a process. Not really weird. It's just kind of weird.
I don't know much about running my own custom processes with it, but manipulating other processes currently running.
Okay. Gotcha. So there may be some weird stuff with running multiple copies. I know with Upstart, you'd have to kind of say, I'm a job, and there are jobs that are dependent on me. It's weird. It's like one job will spin up 5 copies of the other job, which are dependent on it. So if you shut that job down, all of them shut down. It's a kind of weird way to do it, but once you see what they're doing, you're like, oh, that's just awkward, but it's not too hard. But you end up having 2 services on your system. One is the service that launches the copies of the other, and then also controls it to take it down when you want to take it down, because all it does is just link those services together. Because the process is like I start my fancy multi-worker daemon, and that process says just iterate and create 5 processes that have a different number, or however many processes I want. And then the way I shut those down is, instead of having to shut down each individual one, I shut down this virtual process that's managing them, and all those configurations say, hey, I only run if that thing's running. So as soon as that goes down, it shuts down all the children. The other thing I don't have in the slides yet is Docker can make this really easy. How many of you use Docker? Okay. How many of you went to Chris's Docker training? Okay. I don't know. Did he talk about anything about doing like daemon style stuff in Docker? No. Okay. So, I mean, the idea is you have a process that runs in a container. So your container is going to say, I'm going to be a PHP container, and my command is going to be PHP magical script that runs forever and never ends. Then you just have to communicate to Docker if this container goes down, I want you to bring it back up. So Docker Compose doesn't do it, Docker doesn't do it, but if you're using Docker Swarm, which is what you would be using if you were going to deploy Docker into any type of production environment where you wanted to keep other processes up, or if you're using Kubernetes or Rancher or any of the Docker management layers, they will have that in the configuration that, hey, this container, I want it always running, or I want 5 of them always running. So all you do is just containerize your script, which when it comes down to it, we'll look at that a little bit today, is ridiculously easy. It's just, hey, grab a PHP image and pass it to my, push my source code in there and run it. So anymore, I'd say I'm biased that way because anything that I'm doing, I'm trying to deploy using Docker, so it makes sense in the stack that I'm using. If it doesn't for you, I would err towards the systemd side of things and the supervisor-d, but either one will work. This, for example, is a system or a supervisor-d configuration. Again, it's deprecated, but systemd is not too much different than that. So you can see start on these run levels, so 2, 3, 4, 5. So really any run level I'm going to start on. Tells it that, hey, if I die, I want to respawn. And then the respawn with a limit 560 means if I respawn 5 times in 60 seconds, just stop it. Something's really, really wrong. This is important, though. Like, if you have a script and your bootstrap for your script is going to connect to the database, and the database connection goes down for some reason, or there's a network issue, you could hit that really, really quickly. So you need to make sure for these long-running processes that something else is observing them and respawning them, that you bake in a little of a back-off. So if the database, first of all, don't just assume the database works. Do a try catch and be able to understand we had a database error, but don't just exit. Maybe handle that more gracefully. Perhaps even wrap it in a method or function call, at least in your bootstrap, where it says, hey, try to connect to the database. If I can't, wait a minute, try to connect to the database. And if this process goes on for too long, then shut down and expect something else maybe to boot it up again, because maybe there was something with the actual PHP process that needed to be killed and restarted. But just make sure you don't, in any case you can capture, you don't fail too fast, or you'll end up not having your process restarted because of these kind of safety checks. And you can also remove this, but that would be kind of bad because you wouldn't want to keep trying to start PHP if you have something wrong with your file. Here, I'm just saying, hey, this was back when I was running this stuff on Vagrant. So here, I want it to set the user. I'm going to change the directory, so I'm in that directory. I'm just going to execute the file. So this is the command to run. It's PHP, twitter.php, and that thing starts consuming Twitter's streaming API. So any questions there? No, it's all completely obvious. Good. Makes sense. I will take it that way. So there are some alternates that we can talk about. You could, if you're thinking about, I have a thing I think a long-running process works with. I'm not sure. You could look at it a different way. You could use a webhook, right? So instead of a long-running process that consumes another service and says, hey, is there something for me to process, or is there something I need to do? You could build a webhook. Maybe it's like Shopify or Stripe or something like that when an order goes through, it'll send you a notification about that order. So your code, instead of sitting there and saying, every night I batch up things and maybe I ask for this stuff and I work through it, your code could respond to the webhook and then start doing whatever its long process is. thing that you have to remember there is if you're going to do a time-consuming process with a webhook, make sure whatever you communicate back to the other server, they're okay with. So if it's going to take you a minute to do it or something like that, then make sure you communicate that back to the server. Or make sure they retry, right, if it fails. And you can even use a proxy in between this. So if it's a third-party server that doesn't want you to take forever to say 200, okay, I'm all done, then you could use, and for some reason I'm forgetting the AWS service, Lambda. That's the service. You could use something like Lambda or you could use like SNS in Lambda to act as a proxy to say, all right, I get a request from some service. I tell them 200. Cool, we got it. And then I execute from the SNS side a bunch of requests to my Lambda functions, which are webhooks that just code that runs on demand. And those, I actually have no problem with waiting for the service to respond, keeping that HTTP connection open because it's not really long. But I'm going to configure that to, if I don't get a 200 back, I will retry it. So now you don't have to worry about a process that runs for a long time, kind of looking for things, and the queue you're almost doing it on demand by leveraging external webhooks. And then you can also there's external platforms you can use too. So you don't have to do some of the stuff you might not have to do yourself if you don't want to. Iron.io has a whole like a worker queue process thing. It's been a while since I looked at their offerings, so I'm not sure exactly what it is anymore. But there's some platforms that'll certainly take this process and make it easier for you to implement without having. Lambda is actually one of them too. You know, this idea of a webhook comes in, you can run some code and then be done with it. Though I don't think Lambda supports PHP. I think it's just Node and Lua and something else, probably Python. So keep in mind, there are other platforms. This isn't the only answer, but certainly a long-running process is nothing to be, nothing to run away from. So I'm going to skip this thing that says Twitter streaming API example. We'll do that for real in a bit after we take a short break. But let's talk about some concepts here about how this would work. So what do we got here? Some web app needs to send an email to a user. You can certainly do this. Well, say when you have someone sign up for your service, you need to send an email to them welcoming them. And you also need to send an email to whoever owns, say, their account. Maybe it's a new user underneath another account. You need to send it to their admin to say, hey, Bob signed up, just to let you know there's a new person in your group. Slack might, you get a new Slack user in your Slack team or workspace or whatever it is that they call it, and the admin and the user gets the welcome email, essentially. So you could do this in the process. Why might you not want to do this in the sign-up process? Yeah. Could take a long time, right? Well, and those are two different things, right? Because the one thing is it could take a long time for me to hit either an API or create the mail message, render the template, contact SMTP server and send it, or the server could be down. I still want it to work, and I don't want it to stop the user from signing up, because if they can sign up, I want them to sign up. And we want to make sure that it's sent. Any other reasons? There could be a lot of them, right? Anything else? It could be something I would want to wait to do. If they just created their profile, it may be something that I may want to say, well, I want to welcome them to the platform, and I want it to be soon, close to when they signed up. But if I wait 15 minutes, maybe they've finished the rest of their profile, and my message to them can be even more personalized. Right? There may be a reason that I don't want to actually send this welcome email immediately. I want to wait, because the next thing they're going to see after I've signed up is some type of wizardy type interface that walks them through creating their profile. Now, if they exit out of that, I don't want the email to be like something that happens at the end of that setting up the profile, because I need to send them an email as soon as they sign up. But it's even better if they can get to the end of the profile first, so I might throw this in a queue and say delay it for about 10 minutes. Because maybe after 10 minutes there's more information, and when I generate this email, I can generate an even better email for them. So the process is our web app creates a new user and then throws the ID in a queue as a job, and maybe it throws it into two queues. One is the new user queue. The other is the admin notification email queue. So I've got these two jobs sitting around. And then, so my job queue obviously supports multiple channels because I use both of them, right? I have a simple worker that just sits there running as a daemons on some server, blocking, saying to the queue, do you have a new job? And when the queue says, here's a new job, I pull the user data out of the worker, which is probably just an ID, right? I didn't have to pass it the whole user profile or anything. I just passed it the user ID. It then hits the database, pulls the fresh data down, generates the content, pulls all the image assets together and sends the email. This part right here, anything odd about that we may need to be careful with when we're doing queues? Who is writing your SQL queries by hand? A couple of you, all right? Who's using like some type of ORM? All right, who's using, what ORM? Give me some ORMs. Doctrine, okay. Eloquent, okay. Eloquent. So what might you need to be careful about that you don't normally, with all the code that you're writing, you don't normally worry about this, but you're going to have to worry about it here. The keynote speaker talked about this a little bit. Well, no, your queue, if you have, well, so let's first talk about race conditions, right? If you have multiple workers, then yes, maybe you do, but you should be safe from that because multiple workers, the queue wouldn't pass out the same job to, right? So they're each going to have their own job, so they're sitting there, minding their own business, just pulling the data they want. So the entire notion of the queue should, unless we really do something weird, and we queue up the same job multiple times, should avoid any race conditions. What was the other? Something over here. Somebody started. Well, right. So she did talk about, we queued up a ton of queries and tried to hit the database with them, and it just stopped. So I would love to have asked her, like, did you consider like just doing it in mass, like doing one big unsubscribe? Or there's probably a lot of process though behind what goes into taking a user out of a Slack channel that you can't just do it in one database operation. So yeah, you have to be careful about how many workers you have hitting your database. What else?
Is it possible that the user data changed between the time that it was created and when it was fetched?
Yeah, it's possible, and almost hopefully, right? We hope the user has added more to it, because we want to wait for a little bit to send them an email when it's when they've had a little time and maybe there's more of a profile there, but you're close. You're close with the concern. They could have deleted it by that time. Yeah, they could be gone, so we have to be able to say, hey, what if the data's gone? Yeah. Say that again? Oh, there might be another job dependent on it? Yeah, but that wouldn't necessarily be a problem. For those of you who are using like Eloquent and Doctrine and all those ORMs instead of writing SQL by yourself, what is one of the things they give you so wonderfully for free that you don't even have to worry about? Transactions, yeah. What else? Caching. So once I request a user once, Doctrine's like, I got that here. You didn't change it. If you didn't change it, I'm sure no one else changed it because I only operate in the context of a single web request, and those things are usually really fast. So the one thing you have to make sure you do when you're doing this is make sure whatever ORM you're using, you're not just flushing the data, but you're also dropping their cache. I forget what doctrine clear. Yeah, you want to make sure you're clearing it, or you will get into some really annoying situations where you're like, why isn't it doing it? And it's because it already had got that record, and as far as it knew, there was nothing to be done. The state was what it was 15 minutes ago last time it checked it, because it's like, I'm being efficient. I am not going out to the database when I don't need to. So that's one thing you have to keep in mind, that it's a different context, and some libraries, the way they operate, we make assumptions, because everything we do in PHP normally is tied to a web request. So here's a web crawler concept. We've got lots of arrows going around. So there's a database that has some URLs that we know of. These are things that we've already crawled for some reason, or we somehow seeded it. We stuck that data in and said, here's at least a couple pages that you can start with, because you got to start with something, right? There's some data on there, like what keywords were found, what links to the pages have, when was it last updated, all that kind of fun stuff. So we have something here, some process. That's the seed process. This thing runs by itself. There's no other copies of it, because it is going to access the database, and it is going to say, hey, how many pages have not been crawled recently? So how many pages, say, haven't been crawled for a day? Because maybe we have a search engine that we want to re-index a set amount of sites every day. It can make that query, because it can do a query that both selects and marks them as, hey, they're now been at least submitted to be crawled, and it doesn't have to worry about a race condition, because it knows I'm the only process accessing the database. There's not going to be another copy of me running because I did a cron asterisk asterisk asterisk, and it took me more than a second to do my job, and now another process has started and has pulled in the same amount of records. So this process can know what I do with the database. I'm the only one touching it. So when I pull in 100 URLs, I mark them all as submitted, so they're now actively crawling, and I say, maybe it's not last updated. Maybe this field should be, last submitted, just to know, okay, so we've at least stuck in the queue to be crawled, so we're not going to stick it back in the queue at least for another day. All this does is pull all those jobs out that need to be crawled because they're too stale and shoves them in a queue. And then it probably goes to sleep for a while, because it shouldn't be doing that often. It just took all of the records. Maybe it does them in batches because it doesn't want to have a huge bunch of data coming back from the data and lock up the database, which could be a problem. Maybe it just does a limit of 10, submits those, and then says, do I have any more? And then it finds 10 more, submits those, and says, do I have any more? And it finds 5 and says, well, that's less than my limit, so now I've got them all, so I'm not going to ask again. I'm going to go to sleep for 60 seconds and just give the database a rest, and in a minute I'll check again. And if there's not any, or if there's less than my limit, I'm going to just wait another minute. So I'm not hammering the database. And what's nice there is all these workers that we're going to get to, they're going to be operating potentially on this data without hammering the database, because we slurp them up in batches and shove them in a queue. So we have a queue over here that is going to be serving multiple workers, and we set some reasonable timeout. So how long is it going to take to fetch a page? I don't know, 30 seconds? So that's our queue timeout. After 30 seconds, we're going to stick the job back in the queue if the worker doesn't tell us it's done. So what does our worker's job have to do? And we got a bunch of these. We got like 16 of these, or 20 of these, or all that kind of fun stuff. Worker has to fetch the page, so it goes out and says, give me that page, analyze it, do some keyword extracting, extract some links, and then it just pushes an update to the database. So we are hitting the database, but we certainly don't have to pull the record from the database and then update it. We can just update it as needed. And if we want to abstract this a little bit further, it could throw its data into another queue. So instead of 16 worker processes hitting the database at random, there's another queue that's backing up, and it's just making one insert at a time. We're collecting 5 of them, aggregating the inserts, saying I can do a batch update. It can handle that data interaction even more efficiently if we put a worker process in front of here that'll, like I say, we'll collect them up maybe, just go, hey, give me a new job, give me a new job, give me a new job, batch them, and then delete all those jobs. So it's safe. It knows if the batch, if somehow it fails in the middle, those jobs will be put back in and we won't lose our data. And as it does that, if it finds these links, then what's it going to do? It's going to stick a new page in the database. After this thing's done sleeping for 60 seconds, it's going to hit the database and say, is there any pages that haven't been updated? And they're going to be like, yeah, there's a page that's never been updated. And it's then going to stick it back in the queue, and our crawler will slowly start grabbing more URLs until it hits whatever our bounds are, and says, okay, we're not going to crawl these domains. Or if not, then we end up crawling the entire web, and then we become Google. So there's also something here that's important to think of that hopefully we don't have to think of a lot when we're doing normal web requests. What hopefully do you not have to monitor all the time with your web requests that you might need to monitor with something that's fetching a lot of data and then discarding it and fetching it and discarding it? Yeah. Say it again? Yeah, you might need to understand, is my internet connection up or not? What else? Yeah. Yeah, that can happen. Hopefully, though, you're using user agents appropriately and distributing your load the right way and all that kind of fun stuff. But that's a whole different concept here. Yeah, something you shouldn't, maybe you do, but you shouldn't have to worry about that much with page requests that you're going to have to keep an eye on and almost actively monitor. And it's not a code smell that you have to do that here. It's natural for you to want to do it here. Yeah. Memory management. How many of you use the memory managements in your day-to-day web application? I'm hoping. Good. Because if you're like, man, we use 30 meg to serve that page, we need to give more memory to PHP. That's probably a bad thing. But here it's not going to be, because you're going to be pulling in, potentially, you may even run into, if you don't have your worker process taking a look at the content length, you may pull in a really big file and not even know it. So you're probably going to have some code. And like I say, it's not code smell. You're not going to be like, oh, I'm inefficiently using stuff. No, it's kind of normal to look at how much memory you're using, how much memory is allocated to PHP, how much memory your process is using. PHP after 5.3 is a lot better at garbage collection and memory management. But what is very common to see in worker processes like this is how much memory am I using if I'm getting really, really close? One of two things. So when I was building web crawler, we're using curl multi to try to pull in as many pages as possible. So if we saw ourselves getting close to what we defined as the memory, the memory boundary, we'd start not getting new curl handles from curl multi. So instead of fetching 20 pages at a time, we'd slow that down to try to not use as much memory. If that didn't help, if somehow we were still close to our max memory and we didn't have any, we couldn't not pass out any more curl handles because for some reason we just retaining the memory, we would just exit. And we'd exit with a code that wasn't success, so our supervisor D or upstart or something would then just run the process again. So it was natural for our workers to occasionally die because of memory issues, and then they just come back up. And whatever processes they didn't finish, the next worker would finish because they didn't mark the job as complete, so go right back in the queue and process it again. Any questions on any of this? Make sense? So then here's another thing. This might be similar to whatever you're talking about doing, right? We have something that it's some video and maybe audio thing that we want to publish. So we hit the button and say, I want to publish it. So the first type we see is, well, is this video ready for publishing? No, it's not. It's got stuff that needs to be done. So we throw it in all the queues, right? We throw it in the publish and the transcribe, or transcode, sorry, in the thumbnail queue and the keyword queue. So the keyword in the thumbnail queue, they just have to first, they go, oh, wait, has it been transcoded? And they say, nope, not been transcoded. So I can't even do my job yet. So these two workers might say, this job hasn't been transcoded. You want a key, you want a thumbnail, you want a keyword. I can't do that until you transcode it. So I'm just going to put the job back in the queue, but I'm going to delay it. And most queues have this notion of delay. So I'm going to delay it for 15 seconds, 5 minutes, whatever's an appropriate time, and then just wait. So all the lots happen. The transcode thing's doing its thing, and it finishes, and maybe it has the converted file, and it then also throws the job into the thumbnail and the keyword, which is fine because there's no problem with having the job in there twice, as long as these two, when they get it, go, oh, am I transcoded? I'm transcoded. That's great. I'm going to create the thumbnail. And then the next time that job runs, because maybe it comes back, because we put it in a couple different times because we want to ensure that it's done. We're not sure. We want it to be done as soon as possible, whenever it possibly can be done. So it looks and says, hey, if I'm already done, then don't do it again. We're already done. And then maybe these guys, when they're actually complete, will queue the publish job, which will do something similar, which will say, hey, somebody told me they're done with their job. Now I'm going to check, am I ready to be published? And then if all that stuff is done, then finally the publish worker says, publish me, and then remove the job. And should I get another publish request? Because because we got all these things kind of orchestrated, working at the same time. If I'm told to publish it again, I already published myself, so just delete that job. Yeah.
Do the queues themselves have like a deduplication?
Most don't. No.
So could you run into a race condition here that if you have two thumbnail workers?
Oh, getting the same job at the same time. Yes, if you do that, you'll have to be careful about that. So depending on how many workers you have running, yeah, you'd have to worry about that, and then make sure that say, hey, maybe you don't do that kind of overload thing, except for publish down here. So when it first comes in, you do not queue up thumbnail and keyboard. You just queue up transcode, and it doesn't. So thumbnail and keyword are only ever queued up once. But they'll both queue up publish because they don't know if the other one's done. And the publish worker will just sit there, and it'll be a singular worker because it's not a process-intensive thing. It's pretty much change a flag in a database, something like that. So any questions on this? Any just questions that are not on this, but are just in general, like, hey, could you explain that more? No? Okay, cool. We're going to take a break here. Probably, 4 o'clock right now? That's 4:10 actually, wow. Take about a 10-minute break, grab something if you want, and then come back. I'll have my development environment set up to go through a couple of these examples. And then if you want to run through them, let me know. Give me an idea of what you have in terms of development environment set up. If you can run the Docker stuff, great, because it should just work. And we'll do that and tackle that in about 10 minutes. Say again? Docker, okay. Docker, okay. So, how many of you are familiar with Docker? All right, so hopefully this won't be too boring, but I'm just going to explain because it'd probably be helpful as we go through the examples, understand what it's all doing. So this is a Docker compose file, which is just a way of defining a bunch of settings for Docker processes. And so you don't have to, if you run Docker from the command line, you don't have to be like, Docker-V to mount volumes in different places. So just to explain what this file is, at the top here we have the PHP line. Well, first thing is just that we're using Docker 3.1, or the Docker file 3.1. If for some reason this isn't working in your system, you should be okay using version 2. So just changing that from 3.1 to 2, and it should run without problem. If you have an older version of Docker-compose. Services. These are basically containers that will be run. So it's just Docker's way of saying, here's a list of containers we're going to run. Service names, that's what comes next. So we're going to have a service that we're going to call PHP. The build actually doesn't need to be there, does it? Yes, it does. Oh, I just forgot something. I don't want you all to have to build that. Have any of you tried to run the Docker stuff yet? Did it build for you? Fine? Okay, so I won't push it up then. I think I forgot to push that up to Docker Hub. There's a Docker file, but I think I forgot to push the PHP workshop image up to Docker Hub, which I was going to try to do. All right, so it's going up there. We'll see how long that takes. So build just says, here's where the Docker file is if you want to build this. You can ignore this. Build instructions are just what creates the Docker image that will later be used. Here is what I should have pushed before and I forgot about, is the build image up on Docker Hub, which means instead of building this yourself, which is just going to do an apt-get and install some stuff, you can just grab the ready built image. This is what makes Docker so, in my opinion, nice to use, is it's unlike Vagrant or Puppet or Chef or all those things that try to get an operating system to work the way you wanted it to work. It kind of freezes that configuration, as well as not being a VM, and that stuff's wonderful too. But it freezes the configuration so you can say, hey, I have a known good image, I'm just going to run it. It's not about keeping it in sync based off of configuration files. It's about actually just duplicating that file system that worked and running it on a different computer. So the image is what I should have built, and now is going up to Docker Hub. So if you haven't run it, maybe it'll just download it for you. Container name is just what we're going to call this container because we might want to reference it later. Working directory, that's just going to say, hey, when you start this container, make the directory the process starts in /workshop. And then here, this is the kind of important part. It says mount the dot, so my current directory, mount as /workshop. So since this is at the top of my repo, it means all of my source code will be in /workshop on the container. So that'll make it really easy for me to run all of my code there. And then the command for PHP is potentially a little odd, right? You'd expect it to be PHP, but it's not, because we're not serving web pages, right? We're talking about PHP in the command line. So the command is actually going to be bin bash. So this says, when this service runs, I would like you to give me a shell. It also means that when you bring up Docker Compose, this service itself will exit right away, because it'll run bin bash, be like, yeah, that's good, it ran, and then exit, because there's no terminal. So we're using this whole section right here, this PHP section, just so we can store our configuration. We'll launch that by manually from the command line and just refer to this configuration. You'll see how that works in a second. We have a MySQL image, and that's just going to pull down MySQL, set the root password, the database, the user, the actual password to Workshop. Very secure, very hard to guess. And the nice thing is when you use Docker Compose, it creates, now I don't have the definition here, so it'll just take all its defaults, but it's going to create a network that all these individual containers, which are essentially machines running, right, our operating systems running, all these containers can see each other. So they're all in the same network. And Docker has a DNS service which says if you ask for the container by service name, so if I ask for MySQL, it's going to route me to the MySQL server. So if I just say hostname MySQL colon 3306, I'm going to get a connection to MySQL without having to worry about configuration or where it's at or if it's up or down. I can just route right to it. We're also going to run beanstalk-d as an image. That's a worker process, so we'll just run this thing and throw it up there. And again, I'm going to be able to access beanstalk-d by just using the service name, beanstalk-d. Don't have to worry about what its IP address is or anything. And just so we can see what's going on, also going to run a beanstalk console. That's actually a PHP app that'll run and use beanstalk's admin functions to pull out, well, how many jobs are in the queue, let's show the queue names and all that kind of fun stuff, so we can kind of see how the queue's working. Because queues can be kind of mystical because you just stick stuff in there. And then they're there, and you don't really see them because your processes see them. So this will give us a visual representation so we can see what's going on in our queue. The thing that's interesting there is this ports mapping right here. So by default, the Beanstalk console publishes port 2080 for you to access. But since this is all going to be running in Docker's virtual network, from the host, I won't necessarily be able to get to it. Generally, the host is made part of that virtual network, but then I'd have to find the IP address of that service because when I go to my web browser and I say beanstalk-d console, my system's not going to say, you know what, we should probably have Docker route the DNS on that. No, it's going to say we should probably have the DNS server that I'm connected to route the DNS for that. So I wouldn't be able to find it unless I looked up what the IP address is for that beanstalk-d console. This port mapping says take port 2080 on the host, the first one, and map it to port 2080 on that container. So now if I just come in and go to localhost 2080, it will be forwarded directly to that container's 2080, and we'll be able to see the Beanstalk console. Any questions? Roughly familiar? Yes? You don't have to use Docker. If you have a development environment that will run this code, you should be fine. So down here, I'm going to, I'm in the code directory. Oh, looks like we finally pushed that Docker image. So if you run this now, it should pull it down from Docker Hub instead of having to build it. So I'm going to go Docker compose up. And now this is just going to take all of those services defined here, PHP, MySQL, Beanstalk-d, and Beanstalk console. And it's going to, oops, sorry, I'm going to hit Control-C again and just make sure Docker compose down, it's all taken care of. Yep, there we go. I'm going to do Docker compose up -d, which is going to detach it. So now it's going to detach all these processes, it's going to create them, and then it's going to give me back a prompt. So those will just run in the background. If I do Docker PS, not Docker Compose, but Docker PS to see what's running, you'll see we've got a bunch of processes running there. You'll also see that we don't have the PHP process because all it did was run bash and then leave us. But we do have the Beanstalk console, Beanstalk D, and the MySQL. So they're all up and running. This is how we're going to get into this. Everybody's following along. Able to do that? Docker Compose up-D work? Docker PS? All right, so you've got all that set. If you're not using Docker, then the idea is you should just be in your local PHP dev environment, able to run PHP space the script I want to run. So now for those of us using Docker, we'll do a Docker Compose run, do a --rm, which means when I exit this container, I would like you to delete it, because if we don't do that, we'll just create a bunch of containers and they'll hang around, and nobody likes that. So Docker Compose run --rm, and then we'll put in the service name that we want to run, which is PHP. So that's not the command PHP, that's just because I named the service PHP. So I'm saying I want to run the PHP service, and if I do that, it's going to run a bash. Actually, if I do that, it's going to run bash, and let's see if it puts me in there. There we are. And if I do, look at that, awfully clean process list. So now I'm going to do something you'd never normally do with Docker. I want to show you how scripts interact with signals, so I need a bunch of shells at this one container. Normally, if you're using Docker, you'd use different containers for every process you want to run, but I'm going to do a Docker in another window, a Docker attach. You don't have to do this. No, is it? No, it's not attach. Docker exec, and that's going to say execute this process on another Docker image. I'm going to make sure I run that interactively and I get a terminal, and the image I'm going to run it at is, I shouldn't have double tapped that. There's all the running images. I can grab daemon example underscore PHP underscore run underscore 1. That's going to be this process right here because it's the one that's running. And then the thing I want to execute there is bash. So now, nope, not Docker Compose. Oh, can you do an X? Okay.
It makes it easier because if you're in the folder, you can do Docker Compose, and then instead of doing the whole name, you just call it.
Oh, but I can execute two on it? Oh, what if I'm running multiples? How does it know which copy to run?
It'll just do like the attach, it'll exec bash in the PHP container in that like namespace, in that particular folder.
Okay.
Docker Compose folder or file that.
Okay. So now you'll see, wait, I said that, you see. No, I could run screen in Docker, but there's not screen in this image because it's a very stripped down image. So let me just try this again. Exact IT. And that, yeah, that should work, right? It should give me another bash. What I'm kind of not sure of is why I don't see all of them, but is that because I thought again, this is not something I normally do with Docker because this is not something you're normally supposed to do with Docker. Yeah, I thought I could the other day when I was trying this, but so now we've got these 3 windows. You definitely don't need to do this. You can just grab a PHP prompt from the Docker Compose file. Let's take a look at our code here then. So I'm going to walk you through a real simple long-running process, and then we're going to make it even better. So I include some autoloading and some config. Let's take a look at what the config is. I've actually removed my tokens from it, so I have some other config in here, which isn't going to be helpful for you. But and I don't want to bring up the config because this talk is being recorded and the screen's being monitored. But if you look at config dist, this is what it would look like, right? You'd have a very fancy Twitter key, a nifty Twitter secret, some type of a very snowflakey token, and your very own secret. So how many of you have already gotten your Twitter stuff? If you want to follow along, all right, just yes. Oh, you have gotten your Twitter. That was sorry. Other people were nodding. It threw me off. That was 2 signals. Didn't know. So fill those in here. Your OAuth consumer key secret. You can get this from the Twitter dev site really, really easily. I have mine filled in. So we're going to load the config. We're going to create a new HTTP client. I think we're just using Guzzle behind the scenes. We're going to create an OAuth listener of sorts and add it to that. I'm using old Guzzle here, sorry, just because I haven't changed this code example. So this is like Guzzle a couple versions. It's not going to look like the Guzzle you all know and love. At least I think it's using Guzzle. I should probably, let me just check that. Yeah, we're using Guzzle from, maybe I updated this last time. It may be new Guzzle. Cool. So we're going to get a new Guzzle client, set up the OAuth with the config OAuth, so all our tokens, and that's all working. Set up some track keywords. All right, fail, PHP, and my name, right? But let's not do my name because that's a little. Let's do Let's do PHP world. And we're going to throw fail in there because we actually want to see tweets. And maybe we'll reduce that later so we can see just PHP and PH world tweets, but we want to see tweets flow through this thing. And create a new request to Twitter's streaming API, methods post, content type, application, www form URL encoded, all that kind of fun stuff. And we build the query, which is just our track keywords as a comma. Separated list. So this is what Twitter expects us to do. It wants us to connect via post to the streaming endpoint and give them a query to limit it because they won't really give us all the tweets. And if we do this, they're going to give us back the tweets and keep the connection open and just keep on sending us tweets and tweets and tweets and tweets and tweets. The response is we're going to get a response object from the client. So make this request to get the response object. Guzzle gives us a way to get a stream. So we pull back the stream from the client, and then we can use this as a file stream, right? So we can say, while we haven't hit the end of the file on the stream, we're going to read a line from the stream. We're going to call that a tweet. It might not be a tweet, but we're going to call it a tweet. We're going to try to JSON encode or decode the tweet. This may not work. We may find that this fails sometimes, because sometimes Twitter throws in just a new line if there's not a lot of tweets, just to keep things going, and say, hey, it's basically a keep alive. So this may fail, so we should probably have some code here that handles that, but we don't. And then we do if set tweet text, then we're going to do 2 things. We're going to error log the tweet just so we can see it, and we're going to shove that into tweets.txt, so we can store them for all time. And we're just going to throw in the text. We're not going to throw in the huge amount of metadata that Twitter ships down with us. The reason we check this is Twitter Streaming API sends 2 things down. One is a tweet, and one is another body that says this tweet has been deleted. And they ask clients to be responsible, and if they get a delete, to actually delete the tweet. This is example code, and we're not responsible. So we're not going to delete that tweet, because that seems like it would take a lot of work to find the tweet in our text file and delete it. Also, fair warning, we're about to consume tweets from Twitter in real time with no filters. So I don't know what's going to pop up on that screen, but I didn't mean for it to pop up there. Don't complain to Eli. All right, so here we go. If I grab this, so I'm in the Docker container, and I should be able to run. We'll cd into the Twitter thinger, and I called it daemon, didn't I? Yep. So if my code works, this should work. So there you go. There's tweets streaming in. Pretty interesting. How do we stop it? How do we stop anything? Control C, right? And then if we cat tweets.txt, we've got the same thing that we just saw stored in Twitter. So anyway, how do we make this thing better? Let's see what we can do here. Check out. First thing we're going to do is make this look a little bit more. Oh, it's fine. I changed the keyword, right? So that's why I was. So the first thing we're going to do is make this look a little bit more like a regular daemon. So you can just check out Twitter-stats if you want as a branch, or you can make these changes in your file as we go along. I'm just not going to bore you with my typing, but they're not a lot. We're going to add some error logging, because we should tell the user what we're doing as our worker process, as our daemon. So we're going to say, hey, we loaded the config. Down here we're going to say we set up the OAuth. So if something goes wrong, we at least got an idea of what was happening when it went wrong. We're going to track all the keywords. We're going to say, hey, we created the stream request. We connected to the stream. And here's where we change some things. We're going to set a count to 0. So we don't have any tweets processed right now. We're going to say start and time, 2 variables we're going to define as equal to right now, this moment in time. This is the same. We read the line, we decode it. The thing that we changed here is we're no longer error logging the tweet, because that's not something a daemon would do. It would put it someplace, but it wouldn't error log it. So instead of error logging it, we're just going to count. So now we've got a tweet, we've got a tweet, we've got a tweet. And then over here, if now is greater than the last time we set the time variable, or plus 30 seconds, so if we're 30 seconds past the last time we set the time variable, then we're going to error log a message, just a status message to let everybody know we're still here, this is what's going on. We're going to say how many tweets we've collected. We're going to figure out how much time has elapsed since we started this process loop, right? And then we're going to do a little math here and say that the count divided by elapsed divided by 60. So in other words, this is how many tweets per minute we're currently consuming from the Twitter streaming API. And then we'll reset time to right now. So in another 30 seconds, we end up echoing this again. Any questions on this code? It's pretty straightforward. It's not what you normally do with PHP, but it's pretty straightforward. We're just saying every 30 seconds, calculate how many tweets per minute and echo it to, or send it out to error log while you're doing your real work. And in this case, the real work is throwing the tweets into a file. You would probably be processing this or something if you're trying to do some social graph analytics or something like that. So we'll clear that, and we'll run the daemon again. And this time, you can see we have a much more daemon-looking process, right? We just loaded the config, we set up the OAuth, we connect the stream, and now we're sitting there. We're just doing our thing, right? If I go over to another bash process over here, well, first I should be able to see. Now, this is concerning me. There you go. How did I do that before then? Oh, never mind. I know how I did. I think I know how I did before. I wonder if I can see myself. So there we go. We've got all of our got our stats streaming down there. We've collected 241 tweets. Tweets per minute is about 466 tweets per minute. That's pretty fast, right? That's a lot of tweets, and that's just everybody tweeting what's failed, also PHP and my name. But I believe that those are a small contributor to that amount of tweets. And over here, if we do a tail-f of tweets, we'll see our actual data being pushed into the tweets file. I'm not sure. I think there may be a Unicode thing that somehow one of those keywords is picking up a lot of other languages for some reason. But love the emoji flying through there. Basic Windows PC maintenance tips. There you go. It's important stuff. And again, if I do the I should be able to send a kill-s to process 29, right? And there I killed it. So I could kill it if I had somehow detached it, but I didn't because we're not doing that yet, but we'll get to that, right? So the next thing we're going to talk about is how we would actually responsibly handle that SIGINT. So again, all looks real simple, right? We got our error logs we already had. We create our requests, and here's where we change something. We do this whole little run equals true. So now we're setting a run flag to equal true. And we're creating a function. I just did it here because, I don't know, anonymous functions are cool and we should use them when we can, right? So there's a stats function that takes account and when, the Unix timestamp of when it started, and it's effectively what we had inside the loop before. Figure out how many tweets were collected, figure out how much time has elapsed, and then calculate your tweets per minute. And then here's the catch: return time. So whatever calls this is going to expect to get the current time back, so it can reset. It can reset the value that it's going to check to say has 30 seconds elapsed. It's 30 seconds elapsed. But this allows us to use this call in more than one place, right? And then we're going to add this signal. So the shutdown function is going to take a signal, because process control extensions will pass us what signal it received. So we'll just echo that so we can say, hey, we caught this signal, so we know what the signal was, just for fun so we can see it. And we're going to set run equal false. Now note that I had to pass run by reference, right? Because just setting run to false in the context of this anonymous function wouldn't have done us much good. So we pass in run by reference so we can change its value in the function. We declare ticks equals 1. So as often as possible, I want to process these signals. We register the signal handle. So process control underscore signal. We're going to be looking for sigint. And because the first argument to the process control signal is what signal you want to listen to. So we're going to listen for sigint, and we're going to pass that. Our callback for that is going to be the shutdown function. So now we just changed our loop. Instead of while the stream's not end of file, it's while the stream's not end of file, and we're still running, we do all of our stuff. And if the time is more than 30, then we use our stats function to output our stats. And then when we're done, because Control-C now just won't stop the execution of the program, Control-C will simply set run equals false. When we're done, we'll make sure we have one full iteration of that while loop, and then we'll log some things. Hey, we're shutting down, we're closing the stream connection, not that we really need to because it closed anyway, but let's pretend that's important. And then we're marking an archive. So we'll take our tweets text and we'll say, hey, everything else was sequential, but now there was a pause. So we're going to make sure it knows we stopped recording tweets right here at this point. And then one last time, we will output the stats to see what they were at the end. Let's see how that works over here. So we're running our daemon. It's collecting stuff. If we come down here, we can tail-f tweets, so we should see a bunch of tweets. Well, I don't exactly know what that would do. So we see tweets coming in. Let's give it a couple seconds to see if we can see that stats function run. Are those of you who are following along, this working-ish? Or if you just said, this is more fun to watch his computer heavy full of tweets. I don't really need to. So our tweets per minute is 390 right now. I can go again, find what process number it is, 34. So we'll kill 34 over here. And look at that. So our final stats were we got 297, and our tweets per minute were 405. What could we do now to make this better? What's something that if this was a web server, you would want to be able to do without turning it off and on again? Yeah. Be cool if we could change config. So we can use a signal for that. SIG-up is used a lot of times for that. So let's not just listen for SIG-int, which says let's end gracefully, but let's listen for SIG-up and use that to reload our config file. So now we've had to change this significantly. It's still the same thing, basically, but it's a significant change in the code. Now there's going to be this getStream function. And what does that do? That loads the config file, because now we're going to have to do this maybe again a second time. Loads the config file, creates the client, sets up all the OAuth and all that kind of fun stuff. And in fact, this is probably a bit much. I could probably not do that and not have to recreate the OAuth client, but this was the easiest way just to shift the code around. Creates the request with the track. Now this track now is going to be whatever the config file was when it was reloaded, so now we can reload the config file on the fly. Tell the user what's going on, that we're loading the config, creating the HTTP request, and then return that stream. So once we're all done, we will return a stream object from this function. Here's a lot of the same stuff, right? We have our stats call, we have our shutdown call, but then we have our reload call. We'll again echo or error log the signal so we can see it in the process. And then we'll just take stream and we will make it a new stream. Now I know this starts to look a little weird because I'm using procedural code, and it would be make a lot more sense as an object, but I'm trying to keep it simple so there's not a lot of redirection. But that's why we're having to pass some things by reference and using the use for these anonymous functions. But here we just say, hey, pass the stream by reference so we can switch it out. And then whenever this signal is called, get a new stream. Now we just have to register not just sig int, but sig up, point sig up to the right function, and basically it's the same thing. Let's take a look at what that looks like. We'll run the daemon now. You can see got a ton of things just flowing across there, right? This will collect some stats. Come over here to our config file, and we're pulling from here now, which is win PHP and TJ Lytle. A lot more people tweet about winning than failing, believe it or not. And let's just change this to PHP world, and we'll see how that changes. So I hit save. That certainly didn't save it, or didn't reload it. Just changed the file, right? So what are we doing here? We're getting 1,660 tweets per minute. It's pretty fast. So let's take a look at what that process is. 38, but instead of sig in, I want to do sig up and send that to 38. We should then see all this communicated in our Daemons log. That'll still be flowing. And we can see, yep, we caught signal 1. We loaded the config, set up the OAuth, tracking different set of requests. And you can see noticeably how the tweets have slowed down. And now, so this stat is still going to be influenced by how much time during that was we didn't reload it. But this stat will change in a second, and we'll see that it's significantly lower than what it was when we did the reload. Yes? Yeah, these are standards for any Unix-based operating system. Yeah, but you're going to have a problem with that in Windows. I'm not sure what they have there for process control in Windows. So it's still pretty fast, but that's just because, we're an average. So our average is slowly dropping. It's not an average over 30 seconds. It's an average over the whole time. So we'll see that average slow down now that we changed our tracked keywords. Anything about this that you can see any flaws in this scheme? There's a couple problems here. Anything jump out to anybody? Specifically about the reload function? So what setting the run flag to false gives us is it ensures that we have a full run through our while loop. Right here, we no longer have a full run through our while loop. We may be doing something right in the middle, and we're going to pull the stream out and just replace it. It's not going to affect this program because we've either gotten a line from it or we haven't. So it's not going to care if right here I happen to replace the entire stream object, which is what would happen if that's where it intercepted that signal. But if I'm doing something else, this could be kind of detrimental because I changed, like if I use the stream here and I also use the stream here and I also use the stream down here and I expect that to be the same thing, I probably shouldn't have that function just swap it out hard. I should probably have some other type of more complex conditional on my loop that says, all right, we're going to go through the loop, we're going to do some work, then we're going to restart the loop after the configuration's been reloaded. Not going to be a problem here, but that idea is, yeah, you probably don't want to be just swapping out your data right in the middle of a loop. You want to cleanly go through the loop, do some work, and then come back to it. So do we still, oh yeah, now we're slowly seeing our average drop down. And we can still kill the thing like that. Make sense? Any questions on this? Any of you trying to run it, want to run it, haven't run it? Need help running it? No? Okay. I want to show this to you as a upstart thing, but to do that, so you see I exited there and both my other containers went away because I just dropped that container out. To do that, I have to run that here on my actual laptop because, believe it or not, getting Upstart to work in Docker is just like something that no one thinks you should ever do, probably because you should never do that. I mean, you're only really supposed to run one process. So Twitter, let me just make sure it works on my local. I think it does. All right, cool. So I can do the same thing in my local, my local PHP environment's fine for that. Sorry, I don't know why this is cutting this off. This did this yesterday too. I wonder if I can just do one of these and make this thing a little less big. No? Okay. So I'm going to... Okay, I just want to make sure I don't have the Twitter thing in here. So I'm going to copy... It's going to fail because you know what? Root is the only one that can copy that into here. And I know I promised you I wouldn't make you watch me type, but here we are. So I just need to change a few things here because our directory isn't that. It's going to be, I shouldn't delete that whole thing. Yeah, it's going to be home, TJ Lytle, clients. I'm now thinking I could have chosen a much shorter directory name. Wow, I could have, yeah. So that should be that, right? And that's it. Oh, set user ID. Let's set the user ID to, instead of that, anybody see anything there that looks horrible? I mean, I'm doing this on my own computer, so if I do, that'll be the time to tell me. Maybe you shouldn't do rm-f. Everything look good there? Start on all the run levels. That looks to be the project directory. Daemon example, Twitter. Yeah. Let's see how this works. So I should be able to, I'll clear that so you can see this. Oh. That would have worked. Trust me on that. I forgot that I'm so many distros up that I still don't have, they don't have Upstart set on that anymore. So I don't have a good way to demo this. I don't want to bring up the Vagrant box because I tried that last night. It's like, VirtualBox tells us you can't do that. You haven't used it in too long. So take my word for it. What would happen there is even if I brought another process in and I could see the process running there and I did a kill of that process, Upstart would just start it again. So, and what you have to do, the other thing you have to make sure that you define with those things is what should actually kill my process. What signal needs to both be sent to my process? Because Upstart by default, or I don't know if it's Upstart by default, some of these by default will try to, and before I forget, I should probably just remove that configuration because who knows what that's going to do. Some these process managers will by default set a sig int sometimes to close it for whatever reason, and that wouldn't, that would work for us, and that's what we want, right? But some of them will send like a sig, is it sig term, right? Sig kill. Yeah, yeah, but it'll do whatever a kill-kill is, which I think is sig term. Is it sig kill? Okay. It'll send that, which would kill our process dead. There would be no interaction there, so we wouldn't want it to die that way. And what happens is if you or I killed it that way, if we just went and killed the process, it'll restart it. But if you say to Upstart, hey, I don't want to run the Twitter daemon anymore, shut it down, how does it stop the process? And you want to make sure it stops the process by sending it the signal you want to stop the process gracefully. So that's the important thing to remember there. All right, next example. What do we have for time here? 4:56. Okay, so we got time for maybe one or two more here. we'll look at this. This is another, oh, I was testing some things today. Look at that. Bet none of those will delete. It's the other thing with Docker. When you run stuff and create it with Docker, it marks it as a user you can't normally delete stuff as. So here's what we have is a bunch of phone numbers and country codes. And I don't know, we're going to call them or something. But they don't look pretty, right? Not only do they not look pretty, but I'm not sure whether they're an international format. I'm not sure if I want to call them, what number I should use. So I would like to process these things. So I actually have I both validate that number is a valid number, and I get the international and local forms of that number. Seems like a reasonable goal, right? I think that's what the README tells me we're going to do. What does the README tell me we're going to do? It'd be beautiful like that. Look at that. For this example, normalize the CSV list of phone numbers. Okay. Normalized PHP takes a standard in and iterates over the rows. We're going to pass it to the next most number insight API, which the free version will just tell us what the international and local versions are. And our goals are to do two things. So this already exists, and it'll just read through the list, hit the number insight API, and then output row for row the version we want. So we want to do something that will allow this process to be restarted if interrupted. So if something stops, we want it to shut down cleanly so we can say, hey, I think there's 10,000 numbers here, right? So if we got like 9,000 of the way through, we wouldn't want to be like, oh, let's just start that over again. And this isn't Mario World, right? We would want to be able to resume from wherever we stopped, and then allow to make this faster. Instead of just using a single process, why don't I just hammer Nextmo's API as hard as I can? I mean, there may be reasons I shouldn't do that, but why not? Because that would make it easier on me. I could just send a bunch of requests in parallel, and I could get this processed a lot faster. So we'll convert this script to be able to do these two things. Let's take a look at this normalized PHP, see how it works. Again, standard stuff. Get our autoloader and config included. So we create a new Nextmo client. I wrote this client, by the way. I like how it works. I no longer manage it, though, so you can blame me for everything that's wrong with it, and Michael Heap, who manages it, won't have to take any of that blame. And then we just say, while we can get a CSV row from standard input. So we're expecting us to pass a file in. While we can get that row, we're going to create a new PSR7 request, because we can do fun stuff like that. In fact, I'm having to do this because at this point, the Nextmo client did not support this API. So I just had to kind of manually make the request myself and send it with the client. So I'm going to get a request to the number insight basic endpoint, which is free, and I like that too. And then I'm going to create a JSON payload that says, here's the country code and here's the number. Send the request, get the data back, parse it, get the JSON data back, do a little sanity check to say, hey, if I don't get a status back, or if I don't get data back, or if the status is not equal to 0, those are all things that say this was a successful request. So if for some reason it wasn't successful, I'm just going to put that row with null null. So we'll leave that row unprocessed. Just don't add the two extra data points there, and continue. So we won't lose any numbers. We just won't have them. Won't have that extra nicety of it, local and global format there. And then continue just starts the loop again. If we did find number data, we'll merge it with the row we had, right? So we're going to take the first two fields that we already had, tack on the international format and the national format to it, and output that. And this should work. I just have to see, where do we go? I have to go back to where I was, clients. And then do a run. Oh, you know what? I think that'll help me too. Not that I'm going to need that now, but that's what I did different. That's what I did different before. I actually passed bash to docker-compose instead of just having it run its own command. And then I could see all the other processes for some odd reason. Let's try it. I know, it's weird. I don't know why. Maybe it's because I still don't know why. No. Something to figure out later. So in here, I should be able to go to numbers, PHP. Oh, yeah. yeah, PHP, what is it, normalize. And if I just run it, nothing happens because it expects standard input. So I'm going to shove in my input CSV, and we'll see. So each one of those is a web request, and those ones that are blank are probably because Nexmo is saying, no, you've hit us too fast. That's okay. Maybe we can deal with that later, I guess. But you can see. So we got nice numbers, right? Looks good. I told them that I was going to be doing this, so hopefully they haven't just blocked my account. So how do we make this thing better? Check out numbers, and we're going to make it better in a couple different ways. First, let's make it resumable. So here, we'll get to this later. This animation thing is going to be, I don't know, I find it cool, but it'd be interesting to say the least. So we're going to have a count. So we're going to keep track of how many we've processed. Set up some signals. So the process control signal. So if we get a SIGINT, we're going to write to the standard error. And it's important that we're writing to the standard error because our standard out is our numbers flowing down, right? So if we redirect standard out to a file, we'll have a clean CSV file, while our standard error will be what the user sees on the console to tell them, oh, we processed how many lines, and here use -r count to resume. Declare ticks equals 1, so we're checking this signals as much as possible. Oh, yeah, and exit, which is kind of important to do there. We'll use some getOp. If you haven't played with getOp before, it's just a way for PHP to parse the dash flag options from the command line for this current process. So we'll use getOp, and we'll say, this is really simplistic. We'll say, hey, if there was a -r and it really had data, then we're just going to for over our standard in until we get to that point in the file. We could probably be better than this. We could probably seek or something like that, but that seems like it would take someone knowing better how file operations work than me. So we're just going to go over it until we get there. And then we'll write something to standard error, say, hey, we understood that command and we're resuming from line whatever you gave me. Now we'll add a little catch here just to better handle errors that might come from Nexmo. So we'll throw this whole thing in a try block. While we can still get input, do the same thing. Make the request, all that kind of fun stuff. We'll just make sure that once we put the number out, we increment the count. And then we'll do some fun stuff. We'll say we're processing line 1, and then we'll output our animation. And then down here, we will save our last line that we output to standard error. And then if we have a last line that was saved, so if this is at least the second iteration to this loop, we will write that amount, whatever the length of the last, we'll write that to the output. So if our last line was 15 characters long, we will write 15 characters that we've padded with the ASCII character of 8. Anyone know what the ASCII character of 8 is? Backspace. So we'll basically just remove the line in front of us and then write it again. So now we're going to behave a little bit more like a normal command line utility. We're not just outputting stuff. We're actually removing it, and we're being able to say, hey, something's going on here, right? If there's an exception, we will do something interesting. We will error log the exception message to let everybody know what went on. And we will send ourself the SIGINT. So that means I only have to write, I can write the same code, I can interact the same way as every other signal, I can send myself signals. So I just send myself using the POSIX kill, I can send myself my own PID, the SIGINT. This is also stuff like if you were going to demonize your own processes and you kind of monitor them and all that, you'd be using some of the POSIX functions. Which, to come to think of it, I wonder if that's actually part of this image, because I don't know if I tested sending myself those. So this may not work on the Docker image now that I think of it. So now we not only do we want to normalize to put the input. Sorry, it's been a long day. To redirect the input into normalize, but we want to redirect our output into output CSV. And since there's already one of those, let's do output 1. So this means my data in comes from input, my data out comes from, oh, you can't even see that, I'm so sorry. So now my data in comes from input, my data out, my standard out goes to output, and my standard error is going to be what I see in the terminal. So if this works, we see that we're processing a bunch of lines. If we come over to another one, I should be able to, what? Is that what it is? Yep, still 1. So I'm pretty sure the guys at Nextmail are hitting me right now. Just checking that. No, still don't see it. All right, cool. So if I go to numbers, I should be able to tail output. Oh, it's output 1, wasn't it? That's what I called it. Yep. And we'll see. We've got a bunch of this weird stuff going on. I can create an exception for this code by just disconnecting from the wireless. I might not have those POSIX extensions installed on this thing. All right, that's an important thing to know next time, Tim. So let's resume this, because that should have thrown an exception and ended this process. So now I've really done it. There we go. Look at that. I don't know that it was my exception that threw that. But now I Control-C'd it, and we can see we processed, 1,008 lines. And if we wanted to, we know we at least processed that. So if I come over here and see how many lines are in this file, there should be 1,008. I'm kind of afraid to check that because I don't know if my math's right and wouldn't want not be right. But I should be able to resume that by just running this again with the -r, PHP normalize, so -r, and we'll resume from line 1008. And apparently I didn't hit 8, so even though we wrote this nice little program that does that, I completely screwed up my output because the 8 key on my keyboard is a little funny. That all makes sense? How can we make this better? And is anybody trying to run this and running into problems? Because I will certainly help you. But if you're like, it's 5 o'clock at the conference, I don't want to write any code. You write the code, dude. All right. I see how it is. So we also said we wanted to parallelize this process, right? So let's see what it looks like now. Now we have our standard stuff. We're only accepting a file as an argument to say, where do you want me to put this later? You know, what file do you want me to put this in? Because I'm going to do some parallel process magic things, so it's not going to be standard out anymore. I need to know what your output file is. Still take the input through standard input, but the output file, we're going to set a file name. And then I'm going to set up a queue. So this is a Beanstalk client right here. We're going to call the queue normalize, because that seemed like a good name to call it. And we're just going to iterate over our input. For each one, we're going to make a JSON body with the row data and the file name it should belong to. So we're going to create a bunch of jobs in Beanstalk that just have our row and our file name. We're going to understand, too, that we no longer care about the order. If we're talking about parallelizing this, we don't really care about the order that it's going to arrive. It may be out of order from the original file, which is cool. So we're going to add all these things to Beanstalk. And let's just see that in action. So if I go PHP normalize, the file is going to be que.csv, and then we'll push in our input again. Added 10,001 to queue. I really don't know why 10,001 is what we added, but you know, we did. You don't have that in your Docker Compose? So if I go to localhost 2080, here's our Beanstalk queue. We'll bigify this. We can check out this one. We'll see we have a normalize queue, and we have 1,000 or 10,001 jobs in there. If we hit normalize, I don't know. We're just rocking this as an image. I don't know why it's not working. Don't blame me. But we can at least see the next job has our row data, and we could actually, we could delete this job and see the next job. But this is what we pull back from Beanstalk. Here's the code then that handles that, because now we have this wonderful Beanstalk daemon that's going to watch the normalized tube and say, hey, this is the tube I'm working with. Create an XML client. I'm going to register process control signal. Run equals true, right? Declare ticks. So basically, we're just setting run to false if we get a SIGINT. Say we're listening for jobs, and then while we're running, we're going to reserve a job. Now, the timeout's important here. We're going to time out at 10, because if someone hits Control-C and we're just sitting there with Beanstalk saying, give me the next job, we're not going to get that signal. So we're going to wait 10 seconds, and then we're going to basically, if we didn't get a job, we're just going to let, we're going to kind of let the process know that the queue timed out, and then we're going to continue. We're going to do it again. We're going to come back in and wait for another job. Once we got the job, we'll error log that we got it. We'll decode the data. We'll get the data, the row and the file. And now our code looks very much like the other code, right? Same thing. Send the request data, send it to Nexmo, get it back. And here, we're going to open up the file that we want to write to. So whatever file name, because what I could do is I could take a bunch of lists down, just throw them on the queue with different file names. And this worker would go through and it would put each number in the right file, because that's with the job. So it's going to open up the file. It's going to write to it. If there's, again, same logic. If there's no number found, we're just going to write these last two fields are going to be null. If there is, these last two fields are going to be the data we got back from Nexmo, and then we're going to close the file. And here's the important part. We're going to delete the job. If we didn't delete the job, Beanstalk would say, I don't know, I gave it to him. They never said it was finished. And Beanstalk would recycle this, and this worker would pick it up again. And we'll error log that we deleted the job. So if we come down here, we should be able to run PHP. And we're getting a bunch of jobs. If we go over here, we should be able to tail-f, what we call this, queue.csv, and we'll see them all flowing in. And then if I come over here and hit Control-C, we stop, look at Beanstalk, say how many jobs do I have left here. Just refresh the Beanstalk page. We'll see we had, this as long as this queue has been in existence, it's had 10,000 jobs. Currently, we have 9,725. So we're slowly working down our queue. Slowly working down our queue. Make sense? What's wrong with this? What can't I do? Can I launch a bunch of these daemons and have it do all these requests to Nexmo in parallel? That could be a problem. Because if I have two processes that are opening up the same file, both trying to write to at the same time, I mean, file system could handle that, but I'm going to slow it down. I'm going to run into file blocking, and I might get an error, and who knows, and I don't know, that seems confusing. Plus, it doesn't seem like it's good that I'm opening and closing a file every single time a job's processed. That seems like something I could better do somewhere else. So to make it so we can run these things in parallel, we will add another queue. So now our daemon that's processing this, if there's no number data found, this is the only thing that changes. If there's no number data, actually there's one thing I think that changes. Up here, we tell Beanstalk we want to watch the normalized queue. This is the queue that I'm going to consume jobs from. And I want to use the right queue. So I'm going to put, when I tell Beanstalk I want to put a job, put it in that queue. When I want to get a job, get it from this one. So we're watching the normalized queue, and we're putting stuff into the right queue. And now if there's no number data, we will just put in this array that needs to be written. So I'm saying, as part of this job description is write the row, and here's the file you should write it to. If number data is found, then write a row that doesn't have null values, has values that came back from the API, and write it to this file. We'll still delete the job that we got and stick another one in the queue. So if I start running this daemon now, We won't see anything running over there. Not a thing, right? But if I look at Beanstalk and go back to, not that server, all servers, this server, yeah. Go back here, we'll see I have 341 things to be written in the write process. And if I come over here and go to numbers, I can run write, and we'll see, boom. That went pretty fast, didn't it? Oh, I didn't show you write yet. I'm sorry. Got ahead of myself. I was really excited. Write looks the same way, very similar. We set the same type of queue, only now we're watching for write. We will also, respond correctly to a SIGINT. But we do some fun stuff here. We actually track our open files. So if we've already opened a file, let's keep it open. So we don't have to be opening it every single time. While we get a job, while we're supposed to be running, we'll try to get a job. Same concept. If for some reason there's not a job, then we'll just sit there after 10 seconds and process our signals and then go wait for another job. We're going to grab the data. We're going to figure out what we need to write, figure out where we need to write it, and then we'll just write it. We'll see if the file's open. If not, we'll add it to our basically our array of open file pointers, and then we'll write it to that file. We won't close any file pointers because we'll realize that when the script shuts down, PHP will close all the files. But I'll now keep them open so we don't have any file overhead in terms of opening the file. And nobody else will touch the files, hopefully, while we have them open. I don't know if I need to put an exclusive on the mode, but I don't do that stuff that often. So that means you can see over here, my write, we already showed the job working, but it's just saying queue timeout, queue timeout, queue timeout, right? Because there's no jobs in there. If I come over here and I run the daemon, now we'll start sticking jobs in, and we'll see numbers start flowing back into our number. And the other thing is now I can also bring in another copy of the daemon. Now I'm putting twice as many jobs into the queue, and I don't really think that my writer is having any problems whatsoever handling those. So if we continually refresh this, we'll start seeing jobs move back and forth, right? So we're going from normalize over to there, and we're not seeing anybody ready over here. So there's no background, backup on that. Then if I come down here, grab my write job, now we'll start seeing that fill up. Look at that. And if I come down here and hit write again, I'll probably catch up pretty fast. Yep. So now I can run a bunch of daemons pulling data from the API. I'll stop this before everybody gets mad at me for hammering the API with 10,000 requests. They're going to look at the stats and be like, we got so many requests from PHP World. They must have loved our API. They all came from our own client library. An old version of it. No, wait, that's going to point back to me. Oh, well. They're going to know who did it. We're at 5:20. I just want to show you one more thing, and then I'll let you go because I want you to get your full 2.5 hours worth of this workshop. Yes?
A while ago, when I was doing online talks like this, I run into issues with the PHP execution.
Yes.
Is there any concern now?
I don't think so. I think as long as if you're launching it through the command line interface, I don't think it sets that directive anymore. But yeah,
I have to set that to hours.
Could you set it? Doesn't 0 say never timeout?
I might have done that at some point.
Yeah. If you're using an older version of PHP, you'll have to look for that. But I'm pretty sure anything that uses the command line interface for PHP or the SAPI or whatever it is, the CLI SAPI, will not have the timeout. So here's one last thing. Hopefully it works. We've got a really simple CLI that just, we have a service layer that we're just going to assume works because it kind of does. We're going to look for a phone number, a name, a time, and a message. And if we get that, we're just going to shove a wake-up call into a database. So if I come down here, what? My keyboard's acting up. That just created the, oh, really? I didn't fix that. Okay. So that just created a database. So the setup command. So I don't know why I did that. I meant to do clear. Probably because I'm tired. Actually, let's get back into that. So if I do CLI, I didn't update any of these. Oh, wait. That's interesting. I'm just going to check out the completed version. That's why, because I'm not in the master branch. But I'm just going to check out the completed version, and we'll just walk through the code instead of what it was and what it should be. So now that should work, right? So I'm going to put in my phone number. I'll put in my name. I'm going to put in a time. 5 minutes from now, I want a wake-up call that says, "Hey, that was 5 minutes." All right. So, and I should also have, if I do this, yep. So we've got that in the database. So all this is just shoved a row in the database, and we're using a service to kind of find these things, and we don't need to care too much about how that service works. So the idea is we've got a bunch of records in the database that represent when a wake-up call should happen. And now we've got to somehow design a system that will both issue the wake-up call at the right time and not do wacky things with our database. So not do some weird record selecting. And we want to say, since we're, same thing we were doing with the parallel processing for the numbers, since we're making phone calls, we want to make sure we can run multiple copies of our daemon that's going to make the phone calls concurrently. So we don't run into anything like where, oh, you can't make a call because we were waiting for these other calls these API requests actually to finish up. So we want to make sure we can make as many calls as possible simultaneously without doing something weird with the database. So we talked about this in the, like kind of the example scenarios. So our solution for that is this seed daemon, which just sits here. All the standard signal stuff right here, we're going to use Beanstalk for it. And we are going to fetch any active wake-up calls that are supposed to happen within 1 minute in the future. Does that kind of query kind of make sense? So I'm saying if there's anybody we should call in the next minute or before then. So if somehow we just are starting up this right now, I also want the ones that were supposed to be called 5 minutes ago that we didn't call. We should probably, if in practice, this should be arranged, because if like it was supposed to be 2 days ago, probably don't call them. Probably don't want to remind them that we didn't call them. So then we're going to look and say, hey, if the call date, and we'll do for each on this, right? So if the call date is in the future, then we're going to delay that much time. So if, and for a minute, this doesn't make much sense. But let's say I change this from a minute to all the calls in the next hour. So I pull them all out, and I'd say, figure out how far in the future that's supposed to be, and set that delay to 0. Or sorry, not set the delay. Set that delay to however many seconds in the future this call is supposed to be made. This condition right here says, well, if it was in the past, don't delay at negative values. That doesn't make any sense. Just set delay to 0, so there's no delay. Anything seem odd about that? Okay, cool. No questions? Awesome. We're going to throw it and stick it in the queue. We're going to JSON encode just the call data and throw it in our Beanstalk queue. And then we're going to tell the service to mark it as queued. So in other words, update this database record. Say that it's been queued. So this right here is important. This worker must only run as a single worker. But that's why it's asking for calls in the future, so it can make sure they're all queued up. And we don't necessarily trust the queue to like put it in the queue 2 days in advance. That's kind of silly because you don't usually do that with queues. Queues tend not to have persistable memory. So you don't want to put too much in the queue too fast. And then we'll error log that we got it, and we'll sleep. So I don't know, did I take 5 minutes to explain that? Who knows? Let's see. So if I do seed, it'll say sleeping because guess what? I didn't take 5 minutes. So we'll just say 1 minute, right? Because I'm going to look for things that are within a minute, so I should see this. So we added with a 57-second delay. Yeah, maybe. So if I look back over the Beanstalk console, we'll see that in wake up, we have a total job of 1, but it's delayed. So even if I ran my worker, which, let's see if I can do that really quick. It does nothing. Oh, please stop. I don't want you to do it now. So it's not going to do anything. Yes, we got it in time. So it blocked for that 10 seconds. Didn't get a single job because the job wasn't ready yet. So it would go just as soon as the job's ready, and we still see this job. Yep, still delayed. If we look at the wake up tube, we'll probably see we have a request. This one ready? Next job in delayed state. Yep. So we've got one in delayed state. I don't know when is it going to go ready. It should be soon. That wasn't too long ago. So we got 2 total jobs. And see, yep, they're both ready now, right? So as soon as I hit it now, it's going to have those jobs in there. So the daemon itself, very simple. We've looked at this before. We're going to set up an XMO client. We're just going to shut down when we get a SIGINT. We'll reserve. We'll try to pull a job from the queue. If we don't get one, we'll say no job found, and we'll continue. And then we'll make a call. We'll get the call data. We'll make a request to Nexmo's TTS API, which just says, give me some text. I will take that text, and I will call the phone, and I will read them that text. So we'll send that right there. Press get body, write the to, the from, the text. I have my Nexmo virtual number from there, so I actually have a caller ID that it's going to come in as. I'll let the user know that I'm making a call. Send it to Nexmo, get the response, and here I'm going to look to see if the response from Nexmo was 0. If the status was 0, that means the response was successful. So I'll error log that we made the call, and I'll delete the job. If it's not, see right here, if it's not, I'm going to release the job. I'm going to give it a default priority, whatever Beanstalk's default priority. I'm going to delay it 60 seconds because I'm going to say if for some reason it didn't work, I don't want it to be retried right away. I want to back off and at least wait a minute because if for some reason I couldn't reach Nexmo, I don't want to just keep hammering whatever the problem is. Back it off, wait 60 seconds, and then try it again. So now if I come down here and I hit this, making a call. Now they're making 2 calls to me, so I don't know that this will work. So you get 1 call, I'll answer it, put it on speaker. See, it said it really fast before I could even get the speaker. So, and the other one probably went to voicemail. Because it called me twice right in a row, right? But, I mean, if I go back in here and do this, let's see. We can come back in here, wake up. Wow, I can't spell. And then we can do, what was it? It's CLI, and we want a phone number. 1-44-347-2194. A name, which is Tim. A time, which is going to be 40 seconds, right? And a message is going to be hello, hello. A lot of text so it can be heard by the wonderful people in the room. Okay, so we'll throw that in. We see they're sleeping, right? They're all going to wait for another 10 seconds or something. They'll pick it up in a second. And this one, instead of 40 seconds, I'll say, let's do a full 70 seconds from now. So that should distance these enough. How long does our seed worker, it waits 60 seconds. So what we'll do is we'll just come over here. So now we added job number 3 with a 16-second delay. So that should call me in 16 seconds, right? Because this one's kind of waiting around. It's waiting for one to happen. And there we go. Now we got that 16 seconds, so it's calling me. Made the call. I'm getting a call. Swipe up.
A lot of text so it can be heard by the wonderful people in the room.
There you go. And now it's going to call me again in a second because we had, what, another 70-second delay. So this is going to sleep for a while. So any questions with this? Yeah.
When you release the job, can you set up properly on the job for next delay? Here you delayed it 60 seconds. Can you say also on the job set up properly, next delay should be 120, next delay should be 240?
No, I mean if you were going to do that, I don't think you can. I don't think you can change the job data once it's in there. You may be able to add a property. I don't know. And here we go. So this other one was in the past because of how long it waited. So we got our other call coming in.
A lot of text so it can be heard by the wonderful people.
There you go. She seemed very happy about that. What you would do in that case is just delete the job and put a new one in the queue. So if you wanted to add data to the job, like, hey, this has been delayed 3 or 4 times, just delete it and throw it back in the queue. So that is all we're going to do today. Hope that was at least a little bit interesting, enlightening, all that kind of stuff. And I do, if you have a chance, I would love for you to write the talk on joined in. I usually have that in the slide, but for some reason didn't get it there today. I feel like it should be here someplace. Yes. If you want to grab that, or if I do this, anybody have a QR code that they want to shoot it at? Everybody pulls out their phones, not all at once. Okay, no one does that? All right. It's joined in talk B61C9. So if you leave me some feedback, I would really appreciate it. If you have any questions, don't hesitate to stop by. I am generally going to be up behind all the weird computers and tons of wires in the main room. So I will see you around the conference. Enjoy the reception tonight. Thank you.